Alright, let me give you a brief rundown on the market. Now, LiPO was actually developed in Japan in around 1994 by Sanyo Corporation, used in every handphone and laptop in the world ever since. Now, around about 97, 98, I was working with Kokum in Korea to develop high C-rate cells specifically for RC hobby and flying applications. Back then it was 5C, and that was remarkable. What a way we've moved since. Now, almost 100% of the cells are made in China because of the low-cost manufacturing facilities. We are able to leverage off that in Indonesia to pack and assemble our packs and distribution from Indonesia anywhere in the world. Now let's take a slightly more detailed look. Here is a typical lithium polymer battery that's just come fresh out of the factory. Now internally the structure is almost identical from factory to factory. What's different is actually the process of manufacturing. Now the chemistry is identical to what's in your handphone. The only difference is in our application we have the ability to pull more amps. So how do we actually do that? We can see positive and negative collectors coated with positive active material and negative active material separated by a separator filled with electrolyte in between. Now of course in lithium cells, unlike our conventional batteries, we actually have ions moving from one side to the other during the charging and the discharging process. Unlike nickel metal hydride or lead acid, we have electrons. So in actual fact this is a mechanical moving parts product. Thus internal resistance is very important. Okay, now unlike conventional lithium ion cells that you might find in here, manufactured with a winding structure, polymer cells are made on a stacking structure. That is, those positive and negative electrodes are stacked up to add capacity and share the current. Thus we get higher power. Now, how are they actually made? Now it's all made from the mixing of the coating material first. Then we lay the material onto the two substrates, it's pressed, it's slitted, it's rolled, then put inside the pouch and filled with electrolyte. Okay? Now, why are some brands better than others? Now the trick to making LiPO cells is in the coating process. How thin and consistent you can make that coating layers. The thinner the layer and the smoother the layer, the more power you're going to get transferred between positive and negative with lesser resistance. Of course materials have something to play, but if you don't have the right machinery in place to build the cells to the spec that you want, you're never going to get consistent high C-rated cells. Look at this. This is our coating line. It's the only one in China which is spray coating. It can spray up to 3 microns thickness of positive and negative material onto these batteries at the most consistent rate. So after the coating process, the back end of manufacturing and assembly is actually quite similar regardless of what factory is making the cells. The only way to actually truly pick a good cell from a bad cell is by waiting. It takes time. It's called the aging process. Some factories age, some factories don't age. And you can actually see that by the quality of the cells that you get. Now what we do is actually we get our raw cells into Batam, Indonesia, and we age them a second time, waiting for them to change in voltage or IR or capacity, and we measure them on a DCIR process, not ACIR, which all the factories do. We believe we're the only one in the world that actually do this. Match the cells, pack them, and ship them to you. So when you get your batteries in a couple of days' time upon ordering, you know that the DCIR of all the cells in the pack are matched, the capacities are packed, you don't even have to pre-cycle them. You are good to go straight off the bat. Okay, so what's different at REVOLECTRIX.com is that when you order online and within a couple of days of receiving your packs, you know that these haven't been sitting on the shelf. We take the cells that have been aged in our facility, test them for DCIR and capacity, and then match them into your pack. Then when they arrive in your hands by FedEx or UPS, you know they're fresh and ready to go. Okay, RevoBlends.com, we have a world first, something quite interesting. It's high voltage LiPO. And of course we weren't the first to introduce it. these guys were, okay? We were second. So we managed to get the same chemistry, develop high voltage LiPO for RC applications. What's the difference, you ask? Okay, number one, we have two series, blend 427 and blend 435. Basically it means the charging voltage. You'll have to set your charger to 4.27 volt charging for blend 427 and 4.35 volt charging for blend 435. More capacity for the same weight of battery. So actually the lightest batteries in the market. Chargers will have to be set to be able to get the right capacity as per the label and the power requirement, platinum label, silver label, diamond label. As per our website, you'll see the application. Now, how do we actually do it? The chemistry is actually the same. The anode and cathode material have a thin ceramic coating which allows you to charge to a higher voltage above the traditional 4.2 voltage without creating those bloating gases. Okay, so it's the same chemistry that's inside here. We just thicken up the anode and cathode plates, remember from the last videos, in order to handle the higher currents. So of course, what's next, I hear you ask. Now of course these guys are working on 4.60. I know because I'm working with them on the battery design. So we're working on it now, and as soon as we pass safety standards, we'll get them out on reverblens.com.